Everyone, I want to talk to you in this video about errors, type 1 and type 2 errors that come up when we are doing hypothesis testing. You might think to yourself, this seems like a strange thing to do before we know how to do a hypothesis test. And it totally is. This is not the most logically obvious way to present these things, but the reason I have to do it in this order is that the probability of these errors, or one of them anyway, turns out to be a thing that we need in order to know how to do the hypothesis test. So I want to just go ahead and introduce it now, and then I'll show you how to do a hypothesis test in the next video. I'll actually do one all the way through. In the next video. So there are two kinds of errors that we can make. And so actually, let me just remind you that the basic idea of a hypothesis test is this. We're going to write hypotheses, gather sample, and then this is the part where we can get errors. If the null hypothesis is true, then the sample would be really unusual. It means we want to reject the null hypothesis, and not that unusual means we don't reject the null hypothesis. Here's the thing. As always, we are working with incomplete information, so sometimes the sample can just be really weird and cause us to reject the null hypothesis when we shouldn't, or not reject the null hypothesis when we should. And in those cases, those are the errors, right? When we make a decision based in, when I say errors, I don't mean you've done the math wrong. What I mean is the sample was strange and led you to a conclusion that was not actually correct. So here's the basic chart, right? It goes like this. The thing that we think is true, I've put on the top, and the thing that is actually true, I've put on the side, right? So if we think that the null hypothesis is true and the null hypothesis is actually true, so we're in this cell, then great, we made the right decision. Good job. Way to go, us. Or similarly for the alternative hypothesis. If we think the alternative hypothesis is true, and it is also the case that the alternative hypothesis is in fact actually true, then great, we're gonna make good decisions here. On the other hand, sometimes you can get we think that the alternative is true, which is we think we should reject the null hypothesis, but we shouldn't. That's called type 1 error. And then if we do the other way around, the alternative is true, but we think the null is, it's called a type 2 error. Now, it is very, very hard to keep these things straight, at least by name, right? Type 1 and type 2 are not distinctly enough named, I don't think. So let me give you alternative names for them, which are 100% equivalent, which is false positive and false negative. And you have probably heard these terms before, at least at some point. So let me set up an example for you here. So let's say you think you might be positive for COVID-19, right? You seem to have some symptoms, and so you go to the doctor, right? So the default there should be, no, you're not positive, right? What we need to see some evidence that you are positive for COVID-19. And so the doctor is going to run some tests, right? They take a swab, do whatever they do at a lab, and come back with a result, right? So our null hypothesis here is that you're not positive with COVID-19, and our alternative is that you are. So, do I have COVID? I have. Right, and so the default, absent other evidence, is no. No COVID. Smiley face. Or alternative hypothesis, yes. Brownie face. Okay. So you take the test comes back. If the test says that you don't have COVID-19, then we would say that that test was negative. You are negative for COVID-19, right? Hooray, you don't have it. But wait, it is possible that when the test comes back and says it's negative, that you might actually have it, but the test didn't detect it, right? So the test came back negative, but that was false. Just say it was a false negative, right? Option. So let's do this. Test says no. My handwriting is terrible. So option 1. That is to say, test is negative. Oh, that's terrible, but we're going to live with it. Option 1. You actually don't have it, right? Fantastic, right? You really don't. Have it. Correct. It's a correct negative. The test was negative. You are negative. Good job. Option 2, unfortunately, is that you might actually have it. Sometimes those tests aren't correct, and the rates are probably higher than you think, actually. So the test says no, you don't have it, but you actually do. That's a false negative. That is a type 2 error where we think, right, based on the test, that the null is true, but the alternative is actually true. So we should have, in reality, rejected the null hypothesis, but the test did not. Right? The test failed to reject the null hypothesis when it should. So this is a false negative. Let me write that right. This guy, type 2. False negative. That is option 2. Right? Something's gone wrong with the test. The other one works similarly, right? I think I won't write this out on the screen, but let's say that the test says yes. The test comes back positive, which is to say, rejecting the null hypothesis. Well, you have 2 options then. You might not have COVID, which would be a false positive or a type 1 error, or you actually have it, and the test thinks you have it, so it's correct, right? Not necessarily happy news, but at least you know. Right? So that's the basic idea of errors, right? You're doing a test, and this is why they make you take multiple COVID tests, by the way, to do certain things, right? If you want to, gosh, I don't know what you get COVID tests for. I don't get out much these days. But for instance, basketball players. I've been watching the NBA a lot. The basketball players have to take a lot of COVID tests, and then if they fail one, if it comes back positive for COVID one time, then they have to pass like 3 tests in a row before they'll let them get back on the court, right? It's because these tests aren't infallible, right? Sometimes this happens, right? This is given our current level of detection and the way we do it, it's not always 100% right. And in fact, the false positives and false negative rates on COVID tests are actually reasonably high. I don't know what they are. I had a nurse in one of my classes recently, and she said that she thought they were something in somewhere between 10 and 30% inaccurate, right? Which is, not great. That's why you got to pass a bunch of them to do stuff, because you can't be 100% sure that the test is correct. It could be a type 1 or type 2 error. So that's the idea of type 1 and type 2 errors. Let's go ahead and go back to the worksheet here, or the notes, I should say. Right. So what we think is true is what the test is telling us. What is actually true is a thing that we don't actually know. Right? That's one kind confusing or vague part of this. Vague is not exactly the right word, but it's we don't actually know reality. All we know is what we think, right? Based on our test. We can't test, we can't check for everything, right? Just like the COVID test doesn't use all of your tissues and fluids and go through them meticulously to see if the virus is in there. What it does is, well, depending on what kind of test you get, takes a very small sample of your fluids, usually from, you know, your nasal passages, and sees if the virus is in there. And sometimes, you know, you could have it, but the test misses it, or, you know, you just got a weird glob of snot, I guess. Sorry, it's maybe not the most pleasant way to put that. All right, so if the fluids that you provided them are not representative of the rest of your body as a whole, the test can be wrong, right? And that's what we mean when we say an error, right? We got a sample that was not properly representative of the population that we were attempting to learn about, and therefore the conclusion we came to based on that sample was not the true actual correct conclusion, right? And so that's what we're saying with these things. So let's do a question here. I'm just gonna talk through these. These are kind of fun. They're intended to be kind of fun. Maybe they're not, you know, contaminated water and parachutes not working. It's maybe not the funnest things ever, but I'll try to make them fun. I'll give it my best shot. So what I'm going to do here is talk about what a type 1 error would be, what a type 2 error would be, and what it means to be, you know, correct decision, rejecting the null hypothesis, correct decision, not rejecting the null hypothesis, etc. So, right, we've got our 4 boxes here, right? Null hypothesis is true, and we think it's true. Null hypothesis is actually true, but we think the alternative is true, type 1 error. Alternative is true, but we think the null is true, which is type 2 error. And alternative is true, and we think it, and we realize that. So that's good too. Okay, here's the idea. So part A, we've got a null hypothesis of water that is not contaminated versus an alternative of water is contaminated. These things are definitely contradictory, which is what we need in hypotheses. So a correct decision would be the water is actually, or excuse me, if we fail to reject the null hypothesis correctly, that would mean that we think the water isn't contaminated, and it's not, right? We think it's safe to drink, and we drink it, and everything's fine. A correct decision rejecting the null hypothesis would be that we think the water is contaminated, and it is, right? It looks, that water is shady looking to us, and we don't buy that it's healthy. Oh, and it turns out we were right, so we were right not to drink it. Right? For a type 1 error, that would mean that we reject the null hypothesis incorrectly. That is to say, we think the alternative is true, but it's not. The null is actually true. So a type 1 error means we think this is true. We think that the water is contaminated, but it's not. And so we don't drink it. Really, probably no harm done. Maybe we were extra thirsty, and that's kind of a shame, but nothing too bad. On the other hand, a type 2 error would mean we incorrectly fail to reject the null hypothesis. So we think that the null hypothesis is true, but it isn't. So we think the water isn't contaminated, but it is. So we drink it and get sick, right? So bad times all around there. So let me give you a couple of scenarios here to show that, to show different perspectives on this, right? So I gave you kind of the obvious one that everybody thinks of first, where you're at a stream or whatever, and you're thinking about drinking the water, right? And then stream looks clear, so our default is that the water is not contaminated. Our test might be to look around and see if we see, you know, some sort of animal carcass in the water upstream, or maybe there's a you know, a tannery nearby that we're concerned is polluting the water, right? So we might look around for that and see if we think that causes the water to be contaminated, right? But our default, just looking at the water, is that it's not. So different perspective on this. Let's say that you are instead of being someone who is trying to determine if they want to drink at a stream, you are the CEO of a, let's say, paint making company, right? Who has been accused by the EPA of polluting the nearby water. Then you're confident, right? You're feeling good about, hey, our safety regulations, we follow your regulations, the water is not contaminated, right? So instead of determining if you can drink the water, you're really invested in it not being contaminated. So type 1 and type 2 errors have totally different meanings in that case, right? Type 1 error would mean that we reject the null hypothesis incorrectly. That is to say that somebody, let's say the EPA, is convinced the water is contaminated, but in reality it's not, right? This is really bad for you, right? The EPA is going to sue you or whatever, force you to clean up water that isn't dirty. On the other hand, a type 2 error would be rejecting, or would be incorrectly not rejecting the null hypothesis. So in other words, the EPA thinks that the water isn't contaminated, but it actually is. And then the CEO has sort of gotten away with polluting. Okay, let's try this one. Parachute works, parachute doesn't work. If you're jumping out of a plane, your default hypothesis is going to be that the parachute works. Otherwise, you probably wouldn't jump out of the plane. So this makes perfect sense. So if it is the case that parachute works and we think that it works, right? So our conclusion is the correct one, then great, we jump out of the plane, probably have a good time skydiving. On the other hand, if we think that we are convinced that the parachute doesn't work for whatever reason, and then we would choose not to jump out of the plane, well, that's a shame, but at least we made the right decision. On the other hand, a type 1 error looks like rejecting the null hypothesis when the null hypothesis is actually true. Type 1 error means we think that the parachute doesn't work, but it actually does. So we chose not to jump out of the plane, but we could have, and it would have been fun, right? So we missed out on a little bit of fun there, but no great loss. On the other hand, type 2 error is really bad here. Type 2 error means that we think that the null hypothesis is true, but it isn't, right? We think that the parachute works, but it doesn't. And possible disaster ensues. An interesting way of looking at this is that every skydiving death is a type 2 error. There you go. I don't know if that's the happiest or most fun way to think about it, but you can get statistics into anything. So yeah, there you go. So in that case, a type 2 error is much worse. On the other hand, consider the supervillain aspect of this. Let's say that you are hijacking a plane, and you are going to attempt to murder your co-conspirator who is hijacking the plane with you. And so you give them their parachute, and you think that you're trying to give them a defective parachute here, so they'll jump out of the plane, and then you can keep all the money. So a type 1 error would be that we think the parachute doesn't work, but it actually does. So type 1 error is a disaster. You give them the parachute and they jump out of the plane and everything's fine. They just land to the ground. You gotta split the money with them. On the other hand, a type 2 error would be that we think that the parachute works and then it doesn't. So we're giving them a working parachute for some reason here, but then it doesn't. And so they fall to their death, and you get to keep all the money. There you go. I don't know how it's not very realistic, obviously, but whatever. I just wanted to propose a different perspective. Okay, so that's type 1 and type 2 errors. Yeah, I hope that's enough to keep them straight. It turns out that we're not going to be super concerned with the actual consequences of the errors, because we're not doing we're basically learning how to do the analysis, not worrying too much about the real world impact of it. I will ask you a couple questions about these on the test. state what a type 1 error would mean and what a type 2 error would mean, that sort of thing, right? I'll give you a scenario and say, tell me what a type 2 error, type 1 or type 2 error is in the scenario. Or I might also ask something like, we chose not to reject the null hypothesis in this case. Could we have made a type 1 or type 2 error? You know, one or the other or both, and which one and why. And so you'll have to think about that a little bit. So there's a few of those to practice on the homework. So here is why I am introducing all this error stuff to you. It's specifically alpha. We want to be able to talk about alpha here. So alpha and beta are the probabilities of making a type 1 and type 2 error, respectively. Alpha is probability of type 1 error, beta is probability of type 2 error. Alpha has a name and is super important for us. It's called the significance level. We are going to use it in literally every hypothesis test we do. Beta does not have a name. We will never use it. It is called, there is a thing that you would do in a more advanced statistics class called finding the power of the test to compare two different hypothesis tests to each other that we will do none of at all. So you don't even have to worry about it. Do know what it means. Beta stands for the probability of a type 2 error. Alpha is probability of a type 1 error. You've actually seen this alpha before. This alpha is the alpha in Z alpha over 2. So if you remember back from the confidence interval video and homework, I mentioned that the alpha, I couldn't explain what the alpha was yet. And this is why, because I had to tell you about what hypothesis tests were and what errors in hypothesis tests were first. Alpha is the probability of making a type 1 error. I will have another video up talking about why that is a thing that we care about. You're going to want to watch the p-value video first, which is going to be the one after this. But that's what alpha and beta are. Alpha is the probability of a type 1 error. Beta is the probability of a type 2 error. And I think I probably want to leave it at that. Yeah, because we're going to talk about p-values next. And I want this video to be separate from that one. Yeah, so I think I'm going to go ahead and end it there. That's what alpha and beta are. Alpha is the probability of a type 1 error. Beta is the probability of a type 2 error. We will use alpha all the time and beta literally never. Yeah, and we'll show you what you're going to do with alpha and how we use it in the next video. So I'm going to go ahead and end this video right here, and I will see you in the next one.